Today's topic is circles and arcs. We have two objectives: to find the measure of central angles and arcs, and to find circumference and arc length. So our vocabulary, some of this is familiar. A circle is a set of all points equidistant from a given point called the center. A circle is identified by its center. So this is circle E, this is circle O, and this is circle P. Diameter is a segment that contains the center of a circle and has both endpoints on the circle. So here I have diameter AB and diameter DC. Congruent circles have congruent radii. So if these two circles are congruent, then I know OD is congruent to EB. Central angle is an angle whose vertex is at the center of the circle. So COD is a center angle, BOC is a center angle, DOA is a central angle. An arc is a part of a circle. So there are different types of arcs. There's a semicircle, which would be halfway around the circle. From A to B is a semicircle. That arc would be a semicircle because this is a diameter. So I know it connects one point to the other, and that's half of my circle. So that's a semicircle. Then I have a minor arc, which is less than a semicircle. So CA is a minor arc, and then I have a major arc. So ADC is a major arc. So just be mindful that when you're talking about things, what you're talking about, that means their degree measures more than half. The major arc's degree measure is more than half a circle, and a minor arc's degree measure is less than half the circle. So we do measure our arcs in degrees unless we're talking about their length, in which case we measure them in whatever regular distance measures we use, so centimeters, inches, etc. So arc measure, the measure of a minor arc is equal to the measure of the central angles. So let's jump back real quick. So if I'm looking over here and I want to look at this, this circle right here, and I want to name the arcs, I would have arc RS, and it's designated like that, right? And arc CE, let's see, arc TR. These are all minor arcs, so they only have 2 letters, but a major arc would have 3 letters. So if I have TRS, that's the major arc going from T to S. This would be the minor arc going from T to S, which would be this piece. So be mindful, a minor arc has 2 points and a major arc has 3. And I know it's an arc because of the arc symbol versus a line segment. So AB over here, AB is referring to the diameter, but AB is referring to the arc. So make sure you're careful with your notation. Okay, so let's say I want to find the arc measure in this triangle right here, or I'm sorry, in this circle right here. And I know that this piece right here is 32 degrees. That angle right there is 32 degrees. Then I know that BC, the measure of BC, is equal to 32 degrees. And if I know that this is 58 degrees right here, from there to there, then I know that the measure of angle COD is equal to 58 degrees. So they are congruent. The measure of the minor arc and the measure of the central angle are congruent. Okay. If I wanted to talk about, there is an arc addition postulate just like there is an angle addition postulate, right? So angle BOC and angle COD are equal to angle BOD. That's an angle addition postulate. Well, we have an arc addition postulate. BC, the measure of BC, let's do the big arc. Measure of BAD is equal to the measure of BA plus the measure of BD. Okay, so this plus that equals the whole thing. One more time. This plus this equals the whole thing. Okay, so I'm going to find the measures of each arc in O. So I have $32, $58. I know that makes, let's see. Sorry, I got to change my pen. All right. So 32 and 58, that makes this a 90-degree angle. Boom, boom. That makes, and I also know that this whole thing, CA, the measure of CA is 180 because it's half of the circle, right? That's 180 degrees. So then I know that the 180 minus the 32 is going to give me this angle because this is 32, right? 90 plus 32. So I have to subtract the 32. So 180 minus 32, which is going to give me 148. That gives me that this angle right here is 148 degrees. And then I know that this is this is 148 degrees. Let me undo that. This is 180 degrees. This right here is 148 degrees. This angle right here is the 180 minus 58. So this is the pink one. This angle right here is 180 minus 58, which is 122. So this is 122 degrees right here, which is 180 minus 58. Okay. Now, Theorem 10.9 says that the circumference of a circle is equal to pi times the diameter, or the circumference is equal to pi 2 pi r, twice the radius, which is equal to the diameter, times pi. So either way that you want to write your formula for circumference will work. If I want to find the circumference of a circle, let's say that I have that the radius of my circle is, I don't know, 15. Let's say it's 15. So AC, let's say EC is 15. Right, from here to there. And so then it would be 15, the circumference would be equal to 15 pi times, 2 times 15 times pi. I'm using the radius. So that would give me, and you can use 22/7, or you can do 3.14, or you can just put it into your calculator because there's usually a pi button on your calculator. But it's 94.2. So the circumference is 94.2, whatever the units are. So let's say that this is centimeters, this is 92.4 centimeters. That's the distance around the outside of this circle. The circumference is similar to a perimeter, except that no, when I use the word circumference, I'm talking about a circle. So how would I find the arc length? Let's say I want to find the arc length here, not the degree measure, but how long it is, what part of this is. So the arc length is equal to the circumference times whatever ratio of the circle it covers. So in this case, I'm going to tell you that this is, let's say it's 25 degrees. Now let's say it's 40 degrees. That means this is 40 degrees, right? The arc is 40 degrees, but the arc length is going to be 40 degrees divided by 360 times the circumference, which we just found in the last problem, right? And that would be 1 over 9, when I simplify, times 94.2, which gives me 10.46. So that arc length is 10.46 centimeters. Okay, that's pretty much all you need to know in this section. If you have any questions, let me know. Your assignment will be posted. I hope everything's going well for you. Have a good day.